and welcome back. This is the second video in a series where we'll learn how to make a printed circuit board using the program called Diptrace. In this video we're going to make a schematic of the circuit. In the last video we saw how to set up a library and start using the parts from the library. So in this video what I'm actually going to do is I'm going to show you the schematic that we're going to be following, because this is basically what I'm going to be reproducing in Diptrace. So let's start by placing the 555 timer chip down first, this one, because that's the part that everything's built around. So we're going to go here on the left to special, and we go down the list and we see one called the 555 timer. Actually further down the list there's a second one called a 555 timer as well. These are the exact same parts. It's just that one of these parts has a couple of the pins closer together that we need to actually be connected. This one on the right here. So I'm going to use this one. To delete the one on the left, I'm just going to left click it. You're going to see it highlights, and I'm just going to hit delete. There it goes. Alright, so now we got our chip. We can zoom in and out with the middle mouse button, the roll pad. So what I'm going to be putting down first, I always like to start with the power supply. So we have a 9-volt battery charging this circuit. So I'm going to go to basic and basic parts. We got a battery here. So I'm going to put that up near the top because I know that pin 8 and 4 are going to be connected to the positive side of the battery. Now the other part of a battery is the ground. So I know that pin 1 here on the 555 chip needs to be connected to ground. So I'm going to put ground closer to the bottom by that pin number 1. I'm going to put it down here somewhere so it's way out of the way. Okay, and then to get rid of these parts I'm just right clicking to get rid of them. So you can select anything, put it on there, right click to get rid of it, highlight it, and hit delete to delete it. If you need to rotate a part as well, what I'm hitting right now is the space bar, so this rotates it all the way around. So I'm just going to leave it the way it is right there. Next up on our schematic, let's just follow ground to battery to SW1. So this means a switch. So what I'm going to do is in basic parts here we got lots of switches. I'm going to select switch NO, which means an open switch. I'm going to put it close to the battery over here and right click to get rid of it. Now this is going to get confusing pretty quickly if I just put all the parts on here without actually connecting anything, so let's do that next. Let's actually place a wire. Let's place a wire between, and you see how it highlights red here on the negative side of the battery, so that's the negative side, and we're going to put that right to ground. Positive side of the battery goes over to the switch, and the switch, we'll see here, connects to pin 8 and pin 4. So there's pin 8 and there's pin 4, conveniently close to each other. So let's take this over to pin 8, and then we can also select from 8 and go to 4. So it didn't highlight itself red right then, it's highlighted itself blue, and that's because it's already formed a net. So next, the other two pins that we need to connect are pins 6 and 2, so we may as well go ahead and connect those two. 1, 2, there we go. Now we also know that pin 1, ground, needs to be connected to ground, so let's just put that down there. Now see, if I click over here, it doesn't actually connect itself. So I'm going to try that again and make sure that the trace that I want to connect it to actually turns blue. You'll know that there's actually a connection forming when you get this little round dot. If you don't have a dot there, that means that the wires don't touch each other. So if you have a couple of wires that crisscross and you don't see a dot, that means that the traces don't actually connect in the schematic. Next up, let's just go through all these parts and do them one by one. So out of pin 3, let's go to the speaker. So I have a 10 microfarad capacitor and a speaker coming out of this. So let's go up and let's find our capacitors. Look at that, I got a 10 UF capacitor right there, exactly the part we need. So let's put that in. Positive side goes towards the 3, and I also want to connect a speaker, which is just right here. I'm going to connect that fairly close, just put it right there. Then I'm going to connect these to where they need to go. So one side of the capacitor goes onto side 1 of the speaker, the other side of the speaker just goes over to ground. Now, C1, U2, U4, all of these things. We got all of these values which don't really make a whole lot of sense in here. So this is a good chance to go and actually make this make more sense. So we're going to go to View and find a place that says Part Markings. Go across Main, and we want to select the values of all of these parts. See, and it changes a bunch of the labels here. So the value of this chip, this is a 555 timer chip, that labels it correctly. The battery, we know what that is. A 10 UF capacitor, we know what that is. And speaker, that label came up right as well. So if I hit Escape and I just get my normal mouse button here, I can click on the switch. You can double click it, and you get this properties window which pops up for you. So in the value here, you could just do SW1 or call it a switch or whatever it is you want to call it. There, and it calls itself a switch. So this will be more important for the rest of the components because we're going to be placing a .1 UF cap for our other capacitors. But this isn't actually the value of capacitors that we have. We have two other ones to put down. One's a 10 nanofarad capacitor and the other one is a 680 picofarad capacitor. So let's do this one, C3, the 10 nanofarad one first, because it goes right from pin 5 right through the capacitor right to ground. So where's pin 5? There's pin 5. We got the right capacitor on here. Let's spin it by hitting the space bar. Does it really matter which way's up? Nope, because all that we're doing right now is making a schematic which will help us design our printed circuit board. And our printed circuit board, we're just printing basically toner-on copper to eat the copper away and form the traces in between these lines that we need. So does it really matter what these parts are called? No, not right now. It just keeps it straight for us. So this also just connects right to ground. There we go. Now, are these two actually connected? I don't know. Sure looks like it. So what I'm going to do with this one, I'm going to change the value because this was a 10 nanofarad capacitor. Hit OK, and that capacitor is 10 nanofarads. Okay, so next, between pins 6 and 2, we need a trace that comes out. One of them is going to go to the second capacitor here, this 680 picofarad, and then that goes right to ground. So let's do that first. So the same part, let's put it out here. And I'm going to connect, that red trace with that one. And then this needs to go to ground somehow. And now you see how this entire trace here, this is all ground. So it's connected to pin 1, it's connected to the negative side of the battery, negative side of this, negative side of the speaker. So I can literally just pull this up and over and pull it over there. That's grounded now. So the last two parts involve our, well, these are going to be the terminals for our water piano, H1 and H2. That's a fancy way of saying your hand holds one and your hand holds the other one. Not that fancy, I guess. So the first one is probably the simplest. Between pin 6 and 2, we need to connect a 300K resistor, and then that goes to H1. So let's do that first. So we want to select the 1/4 watt resistor. Let's put this, I don't know, up here somewhere. And then I'm going to connect this to pin 6 and 2. How about right there? And then for H1, for the pad, I'm going to use what's called a test point. Now, I'm just going to flip that around. It's going to get a little closer. What if I just put these two on top of each other? Is that connected? Doesn't look like it. See how everything between 6 and 2 is colored blue right now? That's actually connected to 6 and 2. If I highlight this resistor and that one, they aren't actually connected. So let's pull it out a little further. Actually make a trace to make sure these guys are connected. Okay. Let's not forget our values that we want to put in there. So this one's a 300K resistor. And this one is going to be called H1. Okay, we're almost done. One more part of the circuit to connect. So we've got pin 3 out to the speaker, out to ground. We got pin 5 going to ground. We got pin 1 going out to ground. 8 and 4 are all connected to the switch and the ground. That's good. 6 and 2 are connected to everything they need to be connected to. We need to do these two, which are a little bit confusing because there's a few traces crossing over each other here. But basically what's happening is where the switch opens up and connects, so this is where our 9 volts of power are coming in and connecting to pins 8 and 4. We also need that to connect on one side to a resistor, a 10K resistor, and then on the other side of that resistor, that needs to be connected to pin 7. So here's pin 7, here's pins 8 and 4. So let's pick up another resistor, let's put it here in the middle, that works. So I know that one end needs to be connected to pin 7. Oh, that's going to get confusing. Conveniently, we can just kind of pull these traces in and out to make it a little less confusing for us. So I'm going to do that. Okay, so it's connected to pin 8 and 7, and then the other side is literally just either connected to the switch or to pin 8 or to pin 4 or wherever it is you want to connect it. If you ever can't select the red thing there, so I picked this, I deleted it. No, that doesn't work. At any rate, if you ever can't select something, just right click a couple times and then you'll be able to select it. So we're going to pull that over to there. Alright, I think we got it. So let's just double check. Pins 8 and 4 connected to the resistor, connected to pin 7. Oh, look at that, I don't got it yet. We need to connect H2, which is exactly the same as the other ones, except this test point needs to be connected to pin 7. So it's connected here to pin 7, and in order to get through to pins 8 and 4, it needs to go through this 10K resistor. So let's flip that around, put it here. Oh, it jumped over there, sure. And let's connect U to U. Okay, so now we know that H2 here, let's just label this H2. We know that H2 isn't actually connected to the other things because it doesn't have that little yellow dot. If we select H2 or the trace, we can see everything that it's connected to. Let's change the name of this resistor, so that was a 10K. Alright, looks like we're good now. So I know this gets a little confusing when the traces cross over each other. I'm sure we could be a little more creative with this. We could probably pull that all the way over there. There, and then nothing crosses over each other. So I'm going to save this, and that's going to be the end of this tutorial.